Alright, well, looks like a small crowd today, probably. I haven't heard back from Sage yet, so I assume he's probably not going to be able to make it. Sorry, I started coming down with a cold last night, and I probably sound like death warmed over, so I apologize. Let's see here what we got going on. So there's a couple of new pull requests this week. There's a batch list objects to reduce memory consumption that just came in. I'd like to actually know how much that improves things. I'm hoping that we can get some stats on it. But I'm sorry, I don't actually know how to say the name here, but Shishing. But I think they want Sage to take a look at it. There's an async messenger PR here by Haumai that I think it mostly is just reducing lock contention, and apparently has pretty impressive latency reduction effects. I'm really curious about that because we do actually see a fair amount of CPU time spent in the messenger for certain workloads, so that's good. Let's see. I don't know very much about this stupid allocator discard PR. I know we've looked at discard in the past and not really done much with it, but it looks like Igor's reviewing it, so next time we see him, maybe he'll update us on it, but I'm a little nervous anytime we do anything to stupid allocator. Hopefully it's a win. This op tracker stuff that Radoslav is working on is really good. That's been showing up in profiles for a while. Radek, do you want to talk at all about any of that, or is that still just kind of not far along enough?
I've just removed the DNM flag, but still work in progress. Anyway, the compilation on ARMS and cleaning memory is on the board. So even if someone will click the button, there will be no Greek strategy. Anyway, the idea there is to remove. Mostly is to remove the lock that looks perfectly unnecessary. It's a read-write lock that is taken only in the non-exclusive mode, but taken on the main path, on the hot path of execution. Removing it unveiled a high contention we got on the spin lock. On the spin lock guarding the communication part with op history thread. Also, there are some non-related at the moment fixes, mostly for our spin lock implementation. It was using only the compare exchange instruction in vertight loop. That's not the best idea. Just implemented some proposals from Intel and also from GDPC.
Cool. Let's see what else we have. Oh, go ahead.
I was going to say thanks. That looks really good, Radek. Op tracker has certainly been an issue for a long time now, so it's awesome to see that you're able to optimize it that much. I was surprised about the lock part too.
Yeah, I guess it's not necessary. To be honest, I cannot find any purpose for the shared exclusive lock if it's taken only in shared mode.
Mm-hmm.
That's in only my opinion, so this needs review.
Sure.
All right. Let's see. So there's a couple of closed ones here. Both the first one and the second one um, are. I'll maybe talk about them a little bit more in terms of what's the discussion topics below. Um, and then that third one adds minimal tracing for cache activity. I think Sage just closed that. I think he maybe just didn't do anything with it. So that one is no longer there. A couple of updated ones. My PR it sounds like it failed. I think for unrelated reasons. It looked like I need to ask Kifu about that. But yeah, looked like some other stuff was going on. And then yeah, there were just a couple other tests that looks like maybe failed, or at least one, this EC backend one. And then the other ones, I don't think a whole lot was going on yet with them. All right, so maybe before I get into the stuff I have, does anyone else have anything they'd like to talk about this week or bring up? All right, so then I've got two things. The first is related to this change to use BlueFS buffered IO true. So the gist is that we have a user, we had a user on the IRC channel who migrated from FileStore to BlueStore and was seeing all kinds of background work happening. It was like 22,000 read IOPS of just, apparently nothing because he didn't have any client traffic going on. Well, it turns out that this was work created by the migration process. He based on the instructions on the Ceph page, he removed the old FileStore OSD, waited for the cluster to heal, and then put the new BlueStore OSD back in, and did this for every single OSD, and it created a lot of extra background work that needed to be done to clean everything up. And as it turns out, when in BlueStore, when I got him to do a wall clock profile of all this background work, we were spending pretty much all the time in every single TPOSD TP thread in collection list. And eventually that was basically just RocksDB doing 8K reads, most likely sequential, but I'm not sure. It depends on how it was loading the SSDs into memory of all the data. And I don't know how much it was thrashing, but I suspect it was thrashing quite a bit. But that's what the work that was going on is tons and tons and tons of little AK reads. So I had him enable buffered reads, and that seemed to help. Not entirely. It was still doing a lot of work. And some of the threads were still really busy doing reads, but not all of them were anymore. So I kind of suspect that maybe he didn't have enough buffer cache to really like fully cache everything, but maybe it was caching some things, so it was better. But kind of the real problem, right, is that it's doing these little AK reads, and maybe it wants to, but maybe it's really just doing sequential reads. We saw this with compaction too, where it was essentially just doing AK sequential reads when it could have been doing a big like 4 megabyte read of because it was just loading SST files into memory. So for the compaction issue, there's a compaction read ahead setting which we enabled, and that works beautifully. But in this case, that doesn't apply. So we could turn on read ahead in RocksDB, but that may not always be a good idea. Luckily, though, just about a month ago, a PR landed in RocksDB. I've had the upstream that does adaptive read ahead, and apparently, according to their test results, looks like it doesn't really hurt random reads, small random reads significantly, but does help in the case where you're exactly this case where you've got like sequential small reads. So if folks see users upgrading from file store to blue store, and things are kind of like falling over, or just really, really busy. This very well could explain why that is the case.
Mark, I'm wondering if you got any high-level details from like what was going on at this point. Was this all during backfill, and was this particularly bad because there were like a bunch of backfills going on at once, or?
The only thing I got out of the user was that they were doing no client traffic, and they had just upgraded from file store to blue store, and all of this work was coming from the remove work queue.
The remove work queue. Okay, so it's deleting strays at that point.
Yep.
Okay, that's interesting. I wonder if there's something we can fix up at that level to make the the stray deletion or something.
Here's the wall clock profile snippet that he sent me. This is just one of the TPOSD TP threads. But you can kind of, you can see it, all of the time was basically spent in pread 64.
Yeah.
I would, yeah.
I'm guessing that particular aspect of the code is not optimized very much. It's not really been a big deal, and it's only will show up in this kind of grant migration case that you'd have a lot of them going on all over.
Yeah, exactly. I think that adaptive read ahead PR and RocksDB is going to be useful for this and for other things. Mm-hmm. So I'm hopeful that maybe that will help, but yeah, we'll see.
How does that adaptiveness work? Do you know?
What was that?
How does the adaptiveness work in the adaptive read ahead?
I haven't even really looked at the guts of the PR, but I just found it yesterday. Let me link that. It's in the Etherpad here, but let's see.
I got it. Etherpad.
That. Let's see. That's a really simple PR. I think it's just looking if something is sequential, and then if it sees sequential stuff, then
yeah, more than 2 sequential IOs.
Yeah. Yeah, it's just doubling the read ahead size, it looks like.
Yeah, that's interesting.
Well, I think that's in master in RocksDB now. So next time we upgrade, we should be able to play around with it.
Mm-hmm.
We could consider bumping up the static read ahead in RocksDB now, but I don't know if we really want to do that or not. Maybe with compaction, it was kind of a no lose situation because it's just reading the whole thing in anyway. So it's always sequential. Yeah, I don't know.
Yeah, the adaptive bit seems like it's surprisingly simple, but surprisingly effective. So if we could pull that in next time and see how that works, I think that would be the ideal path.
Yeah, I agree. So that maybe is a good segue into the next thing here. So I have been starting to look at making a mechanism for rebalancing the caches in BlueStore and RocksDB. And I think I've got a plan that I think is going to work. RocksDB, at least so long as you're using the LRU cache, has a concept of a high priority pool that you can reserve in the cache for things like indexes and filters, but it doesn't really expose very much about it right now. So you can't find out how much space in that high priority pool is being used. And it's just kind of inflexible in general. So what I'm doing now is modifying some of that in RocksDB to try to make it so that I can kind of control, monitor and control that more in a more flexible manner. And then in BlueStore, I can piggyback on the mempool thread where we're already flushing the cache, and do some rebalancing in there on kind of a periodic basis. So maybe this is once every 10 seconds, maybe it's once every 60 seconds. I don't know. We'll see how much overhead it is. But with this, then we can do things like say, okay, always make sure that we've got enough space for high priority items in RocksDB's cache plus 20% or something. Then after that's fulfilled, we can say, okay, now based on how many O nodes we have and how much OMAP we have, maybe we start making decisions on whether or not we think we want to prioritize O nodes or we want to prioritize OMAP, or maybe some kind of balance between the two. Depending on if we're dealing with RGW or RBD or something else, whatever. And then finally, after all that's done, we might say, well, now we want to take whatever we've got left over and dedicate it to maybe, data, or, maybe extra space, even more extra space in RocksDB for caching, for avoiding reads during compaction by just having SSTs kind of already there, or maybe we're still going to be using buffered reads, in which case RocksDB can just read from page cache, SSTs from page cache if it can. But this gives us a lot more flexibility, I think, and lets us kind of start getting away from this idea of static caches for things and letting Ceph make smarter choices about it. I think it's going to be a lot better if we can kind of get into that mindset. So I'm going to try to have that, at least a prototype for that sometime in the next week or two here, and then try to get whatever changes in RocksDB I need submitted upstream. And between those, this new adaptive thing, adaptive read ahead, and then Radoslav also has a PR for oh, sorry, Radek, I already forgot what it was that you made. But yeah.
Just two PRs, one related to squashing the abstraction layers over key comparison in RocksDB. Second one for avoiding some decoding, some unnecessary decoding on each key compare.
Yeah, that one. So once all of those are maybe if we can get those merged upstream, then I think it'd be a good idea to bump RocksDB up to the newest version again.
Cool. So then have you been testing already with your prototype for the dynamic cache?
So my prototype right now, all it does, it doesn't actually adjust anything right now. It's just monitoring different sizes of things and starting to pull the stats in. So once I kind of am satisfied that the stats kind of make sense and are telling me what I think they're telling me, then I'm going to try to start making decisions based on it.
Okay.
But the good news is that I can actually get all of these stats now, whereas before we didn't really have anything. So now I'm actually, I'm running different workloads and actually watching the high priority cache items in RocksDB increase, and sometimes like spill over into the non-priority pool. But you can tweak that kind of stuff, like how much space you want in each. So part of this will be just kind of trying to figure out what ratios make sense, and kind of always what we need to do to always keep ahead of so that we're always maintain the caches where we want them to be.
Right.
Yeah, so not a whole lot yet there, but it's kind of the start, and I think from what I'm seeing so far, it all seems like it kind of makes sense, and I'm hoping it will we'll have a nice graph showing that the caches are rebalancing and the hit rates are better.
Yeah, I'm looking forward to that.
Me too. Well, that's all I've got, guys. Any other last minute things before we wrap up?
Maybe just a quick note on the Mutex implementation from glibc. Basically, it doesn't try it doesn't try to spin even for a second. All it does is to check the atomic value inside, and if it's locked, then just go to kernel. I create as a part of the tracker rework, I've put a small thing called adapt guard. I guess the better name would be trying guard or something like that. It can be used to like uniclog, just like uniclog, but before going to actually locking a mutex, it tries several times to try lock. So basically, it's a combination between spin lock and mutex. May be useful to applying in other places as well.
Did you give any attention to the fact that on glibc, modern glibcs, that behavior is already in pthread mutexes?
I've checked the implementation of in glibc.
I mean, it does spin, right?
Yep, it doesn't.
Well, it certainly used to.
At least at the version. At least at the version I was checking, it was if I recall correctly, it was 2.27.
That's very confusing. Okay.
Yeah, I think there was a talk at the open source summit in this past fall about something like this with glibc, but I don't think it was upstream yet. So that.
Yeah, remember that from like years and years ago. That's what's confusing about it.
Yeah.
Yeah, but
I think the BSD family used to do that, but I'm not sure that Linux ever did.
Madness.
It might help for the contention scenario, but however, if it is useful, it means that most likely you will need to change your algorithm or something like that, because you have contention. I treat the trying guard as a makeshift solution before going to C star.
Yeah, makes sense, and especially if it helps out with some of the other things that we want to optimize. It should. I guess it will be interesting to see which areas it does help, because that would indicate that they did have contention there before.
All right. Well, I guess unless there's anything else, let's wrap up this week, and we'll meet again next week. All right. Have a good week, everybody.
Later on.
Thanks.
Yeah.
Same for you. Bye.